First, we're going to start with Photoshop. My canvas is set to 32 pixels by 32 pixels, but for animations, we will need to extend that. First, we're going to enable the pixel grid. Go to View, then Show, then Pixel Grid. Next, we're going to set our brush to pencil. Right-click on Brush and select Pencil. Then we are going to need to set up our pencil. The brush size will need to be 1 pixel, and we will need to have the hard square 1 pixel. If you do not have legacy brushes enabled, you'll need to enable that first. Go to the settings button at the top right of this panel and click legacy brushes. There you can search hard square 1 pixel. Next, we will set up our eraser. Click on eraser and make sure mode is set to pencil. It will also need to be set to hard square 1 pixel and be a size of 1 pixel. As a quick tip, it will be easier to see the pixel grid that we enabled by changing the background color. I'm just going to set mine to a light gray. You will want to add another layer, however, if you do this. I will quickly make a couple of assets that we can import into Unreal. Alright, now that we have our assets, we can go ahead and export this as a PNG. As you can see, I did change the size of my canvas. If that is something that you need to do, go to Image, Canvas Size, and change it as needed. To export, there is a quick Export as a PNG button under File and Export. Let's go to Unreal. In Unreal, I do find it's easier to work with a blank template game. For the purpose of this video, I also opted out of starter content, and I will use blueprints to build this. We'll go ahead and add a new empty level, and we'll call it tutorial level. Now we'll import our assets. I find the easiest way to do that is to drag and drop from File Explorer into your game. As you import them all, you are also going to want to change a setting on them. Right-click, go to Sprite Actions, and apply Paper 2D Texture Settings. You'll need to do this for all of them, including assets like a ground. For the ground, a lot of the time you'll need to make a tile set, but for the purpose of this video, I will just be using it as a normal sprite for the character to walk on. I'll still show you how to make it though. Right-click, go to Sprite Actions, and create tile set. You can change the tile size as needed. I'm going to change this to 16 by 16 so you can see a square actually highlighted. Right now this doesn't have collision. Click Add Box, and it'll add a collision. To see it, you can click Colliding Tiles. Go back to the level, right-click on the tile set you just created, and click Create Tile Map. From here you can click a tile that you're ready to use and paint it on the canvas. Then you can drag and drop into the scene. Like I said though, I will just be using the ground as a normal sprite, so I'm just going to click Create Sprite. Either way, you do want to have the location values at 0. In order for the character to walk on it, it will need to be rotated minus 90 degrees on the x-axis. If you can't see this orange border around your sprite, click Show and Collision. Next, we'll make the character. In the event that you have a sprite sheet, you'll want to click Sprite Actions, Extract Sprites. From there, it automatically tries to find the sprite, but if it's being funky, you can click Grid and resize it. What it'll do is create textures for each of the sprites, just like these. I do want to mention this, if you start with auto for the extract sprites, you'll want to stay with that. If you start changing between auto and grid, it'll make some inconsistencies with the animation. Since these are still just textures, you'll need to go to create sprite. And from there, with both of them still highlighted, you can click Create Flipbook. This is the animation for the sprite. Right now it's way too fast, so I'm going to change this to 60. I'll click these drop downs for the indices, which are just the sprites, and change the frame run. Since this is supposed to look like he's blinking, I'm going to make the first sprite frame run a little bit larger than the second. Normally you'd want to have them even though. You can play around with the frame run to make it as fast as you want. We'll need to do this for all of the sprites animations. Next, we'll make the character blueprint itself. Instead of using the character common blueprint, we're going to go down to all classes and type in paper character. Inside you'll find a capsule collision. In the components panel on the left, you'll want to click sprite and choose the flipbook that you want to use. We'll start with idle. Since this is a top-down game, we will want to rotate him negative 90 degrees on the x-axis. Then we'll need to scale the capsule collision. You can do that under shape in the details panel on the right. Next, we'll add a spring arm and a camera. For the spring arm, we'll need to rotate it -90 degrees on the y-axis. With it still selected, we'll search for a camera and add that too. This will also need to be rotated. On the spring arm, we'll need to change rotation to world, and then also uncheck do collision test. This will be important later. If you need to zoom the camera in or out, I recommend using target arm length instead of changing the location on the camera. If you'd like to adjust the brightness of the camera at any point, you can find that in the details panel by searching max brightness or going to post-processing, lens, exposure, and then checking this box next to it. For a moment, we're going to drag and drop the character onto the scene. I am going to scale up the size of this ground. As you can see, we're not using the camera that we just used, but we'll fix that in a moment. I will now delete the character and replace it with a player start. That's in the objects dropdown box under basic. Make sure that that is also set to 0 for the location values. I'm going to scale it down to more closely match the size of the character. If you see that bad size sign, that just means that it's intersecting with collision. Next, we'll add a player controller and a game mode. We'll go to add blueprint class, and both of these can be found here. We'll start with the player controller. I named it the same as the project. We'll do the same for the game mode. We'll go ahead and open the game mode. If you'd like to see the full blueprint editor and the viewport, you can click on this button. For now, we'll stay here. There are a few settings that I will need to change. For player controller class, we'll need to change that to the one that we just made. And the default pawn will be our character. We can close this for now. Go to Edit, Project Settings, and click on Maps and Modes under Project. Here we can change the default map that the editor opens up to, as well as the game. We'll change these both to the level that we're working on. At the very top, there's a default game mode that we can change to the one that we just made. Even though we're working with pixel art, we will still want to have anti-aliasing. This will make a difference with how the camera views everything. We'll go to Engine, down to Rendering, and then we'll scroll down about halfway to Default Settings. Anti-aliasing method is towards the bottom. We'll click on the drop-down box and click FXAA, or Fast Approximate Anti-Aliasing. Just above it is Auto Exposure, which you can also change if you find the need to. Next, we'll add the character controls. That used to be under Engine Input, however that's been deprecated, so we will not use that. Instead, we'll go to Add in the content browser, down to Input, and click on Input Action. We'll just name this IA Move. Inside, we'll want to change the value type to Axis 2D. That's all we need to do for that. We'll go back to Add Input, and add an Input Mapping Context. If you've added player controllers before, this will look familiar. Under Mappings, we'll click the Add button, and choose the Move action that we just made. Under there, we can add buttons for the control, which we will use the standard WASD keys. If you click the keyboard button, it'll let you click the appropriate key on your physical keyboard. To add more controls, we can click the plus button. For the D key, we'll go to Modifiers and click the plus button, and we'll find Swizzle Input Axis Values. For W, we'll add a modifier, Negate. A will have both modifiers, negate and swizzle, and S does not need any. With just this one input action, we'll be able to move in all 4 directions, and how this works is with the modifiers. Negate will take the control and invert whichever direction it's supposed to go, and swizzle will turn the character 90 degrees, kind of like a swivel chair. We'll go ahead and go back to the character blueprint, and make sure to be in the event graph. This part might be scary, so just stick with me. We'll start with a clean slate. Right-click and type Event Receive Controller Changed. We'll drag out the execution pin and search Cast to Player Controller. The object pin will need to connect to the new controller pin. I will also add a print string here just to make sure everything's working. From the casting node, we'll drag out from As Player Controller and search Enhanced Input Local Player Subsystem. You'll want the one under Player Controller. From that, we'll drag out and search Add Mapping Context. We'll also connect the execution pins. Under Mapping Context, select the input mapping context that you made. Make sure to compile and save. Find a blank space, right-click, and search Enhanced Input Actions. You'll want the one under Events. It'll have the same name as the input actions that you made. Right-click on the action value pin and click Split Struct Pin. Add a movement input node and connect the execution pins to the triggered pin. If you use the dropdown, it'll show you a bunch of others. We don't need those right now. Find the action value X pin in the first node and connect that to scale value. Drag out from world direction and search Get Right Vector. You'll want to split this purple pin. Drag out from the first pin and search Get Control Rotation. This will also need to be split. Connect the first and last pins. Add another movement input and connect the execution pins. This one will attach to the action value Y. For world direction, we'll drag out and search get forward vector, split that pin, and grab the last pin, the yaw, and search get control rotation. Make sure to split that. We will add a few print strings. The first two will go between the two add movement inputs. The pink pin will be connected to the action value X pin, and we'll type up down. We'll add another two after the second add movement input. In the first of this pair, we'll connect the in string pin to the action value Y. This one will be for left right. If you're getting this error for get control rotation, search for it again and click on the second one. This one targets the pawn as opposed to this one that targets the controller. We'll go back to the level and click add, and then under create advanced asset, we'll click blueprint enumeration. This will be for the types of movement that the character can do. We'll open it up and click add enumerator for each movement. This includes idle, so there will be 5. Go ahead and save and close, and we'll go back into the character. In the My Blueprint panel on the left, we'll add a function. This will be for the character's animations. Compile and save and go back to the level. We'll try to move the character, and you can see on the left the values changing. We need to write those down. Then we can delete the print strings. Don't worry about reconnecting the execution pins for now. Drag out from the first add movement input and search branch. Drag out from true and search for your function, and you can see that there's no options here. We'll go back into the function and add an input, which we will call animations, and we'll click on the bool drop-down box and search for our enumeration. Now if we go back to the event graph, we have some options here. This first one coming out of true will be for move down. We'll make one for false that will be for move up. And we'll search with the greater than symbol. From the top pin on the left, we'll drag this and connect it to the action value X pin. We can leave this as 0. We'll repeat all 4 of these nodes for the second add movement input node. This one will connect to the action value Y pin, which can also be left at 0. The animation that comes out of true will be for move right, and false will be for move left. Now we'll add some checks to the beginning of the cluster. We'll go ahead and put a print string right after triggered. Then we'll add a branch, and true will connect to the first add movement input. False will then connect to another branch, and this true will connect to the other add movement input. From this last branch, the false pin will connect to a print string. This will be our error message. Both branches in this pair will need to be connected to an OR boolean, and both will need to be connected to a greater than and a less than node. From the first set, the first pins of both the greater than and the less than nodes will need to be connected to the action value X pin, and both can be left at 0. The opposite will happen for the next two. They will be connected to the action value Y pin, but they can also both be set as 0. Now we'll add a new variable. This will be a float, and we'll call it movement action value. From the first branch of the pair, we are going to instead put a set movement action value node between it and the first add movement input node. This can be left at 0. From the enhanced movement action node, drag out of the completed execution pin and add a print string, and connect this to another set movement action value. Lastly, we'll add the function. This will be idle. So what is this all doing right now? When the player uses the WASD keys, it'll check the value of each key. If up or down has a value greater than or less than 0, it will continue down this line. If it doesn't, it'll check to see if the left or right movements are greater than or less than 0 and move down that line. Once the button is released, it'll switch back to idle. I'm also going to add an event begin play and connect it to the function, which we'll leave at idle. This is so that the character doesn't begin running the moment the game starts. Make sure to compile and save. Now you'll notice nothing's happening, except for a lot of print strings. This is where the function needs to be built. If the spaghetti monster stresses you out as much as it does me, here is a nicer view of it. In the function, we'll immediately connect this to an isValid node, the one towards the bottom with a question mark, and the input object will be getController. It should say pawn. From the isNotValid pin, we're going to connect a print string. And from the isValid pin, we're going to search for switch on and the name of your enumeration. We'll connect the character animations pin from the function to the selection. The next steps might look a little scary, but I promise it's not that bad. From the idle pin, we'll drag out and search for set flipbook and find the idle animation. We'll want the target for all of these to be the sprite, which you can drag out from the components panel. I'm going to add a print string at the end. From the move up pin, we'll need another set flipbook and connect the sprite node and find the move up flipbook. And we'll repeat this for the move down animation. move left and right are going to be a little bit different. We'll still need the set flipbook node and connect it the same way, but from there, we'll need the set relative rotation node. It should be the one under transform. The target is still the sprite, and we'll need to change the X value to -90. This is so that the character doesn't stand up to where you can't see it with the camera. Since this is move left, we'll also need to change the Y value to -180. However, when we do move right, the Y value will be 0. So we'll go ahead and repeat this for move right. Now when we go back to the level and hit play, we should see it moving, and you should be able to see him blinking as well. If you would like to see a nicer image of the function, here you go. Congratulations, you have just made a 2D sprite in Unreal Engine 5. If you have any questions, please feel free to reach out.